Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to start discussion on Kafka cluster with multiple brokers. Okay, so in my previous videos, I have already covered Kafka installation in our local system. I have discussed how you can connect Kafka with Python, how you can start multiple producer, multiple consumer in your locally running Kafka cluster. Then I have covered how you can basically create a topic with multiple partitions, and we did inspection on Kafka log directories as well, that is zookeeper logs as well as server logs, right? So let's now start discussion on multiple broker Kafka cluster, how to do that setup. Okay, so in my previous video I have also covered this topic, that is generally we don't have one single broker or one single Kafka server in our production system. Okay, because if that particular server goes down, then the whole cluster will be down and no producer can publish messages in the topic, no consumers can consume. Okay, so to overcome this particular issue in any companies, whenever we work in production scale Kafka cluster, then instead of one single server we are having more than one server, which we call as cluster of servers or broker cluster. Okay, because multiple servers are there. Okay, right? And like here you can see, I am going to start three different servers in three different ports in our local host. Each broker is basically having their own unique ID. Like here, this is having broker 1, this ID is having broker 2, and this for this server the ID is 3. Okay, like that, three different servers are there. Okay, and we are going to create a topic in this kind of cluster of servers, which is basically running in our local system. Okay, right? So in my previous video, I have discussed topic with multiple partitions, right? So this time we are going to create a topic with 5 partitions. Okay, and what happens in the back end, that whenever you are creating topic with multiple partition and you are having more than one server, then the Kafka will not create all the partitions in a single broker. Okay, it will split different partitions randomly in different brokers. Like here you can see, suppose the topic name is A, then if we are having 5 partition, then partition 0 and partition 2 are coming in first server, partition 1 is coming in second server, and partition 3 and 4 are coming in another server, like that. Okay, so just remember this point. If you are creating topic with multiple partition, when you are having more than one server, then Kafka will try to create partitions in different servers. It is not like all the partitions will be created in one server only. And you might think why. The reason is very simple, that is, suppose you just think all the partitions are created in this particular broker 1 server only, then what would happen if the broker 1 goes down? Obviously the topic will not be accessible. The complete data, whatever stored in this particular topic, as all the partitions are in broker 1, this server only, and if this server is down, then that messages cannot be consumed by consumer, and producers also cannot publish messages in this topic. Rather, if your partition is basically distributed in between different servers, what would happen? Suppose my broker 1 is down, then in that particular topic only partition 0 and partition 2 data we will not able to access whatever already stored earlier, but in partition 1, partition 3 and partition 4, producer can publish messages and brokers can store them in hard drive in append manner in the log locations. Okay, and consumers can consume from that. Okay, so in simple words you can understand easily that if the partitions are distributed among different servers, then if one server is down, then only that data which is stored inside the partitions in that particular server, those will not be accessible. But it is not like the complete topic is not accessible or the complete data present in that particular topic is not accessible. In the other partitions, in the other servers, whatever data is there, that will be still accessible. Okay, that's the simple concept, and that's why whenever a topic is created with multiple partitions in a cluster of servers, then partitions are distributed among different servers instead of placing all of them in one single server. Okay, that's the simple concept. Now without any further delay, let me start my discussion. So first here what I will do, I will just show you that if my server goes down in a single server Kafka cluster, then in that scenario the producers and consumers cannot work. Let me just show you that. So as a first step, what I will do, I will basically start my zookeeper, and here you can see the zookeeper is running in this port, and then here I will start my broker or Kafka server in another terminal, So here my Kafka started. Even if you want to get some information about the running servers, okay, then always you can use this particular script. There is a script zookeeper-shell. So here you just need to mention your zookeeper server which is running in our localhost 2181, and then here you can print the broker IDs. Okay, so currently we are having only one server, and if you recall in our previous installation process, here in the config, if I go to server properties, so this is basically our broker server configuration. So only broker ID 0. So currently we are having only one single broker in our cluster. Okay, so if I run this particular code to zookeeper-shell.bat, show the list of broker IDs, then I will be only getting 0. Okay, let me just show you that. In another terminal I will be going, I will paste that and I will hit an enter. Okay, sorry, it will not be sh because we are running in Windows machine, so it will be that file, and I will hit an enter. So here, unable to read additional data from the server, error exiting. So here it is giving like this way, connected to localhost 2181. My zookeeper is running, right? Port 2181, yes. Session for server closing socket attempting to reconnect except is a session exception. End of stream, unable to read additional data from the server, likely server has closed socket. Okay, right, so we are getting this error, so let me do one thing. I'll just come out of this and I will terminate my zookeeper also. So all I will do, I will go to zookeeper.properties, and here possible maximum connections I will make 0. 0 means unlimited connections possible, and let me try with this property once. So here I will start my zookeeper again. So here my zookeeper is running, and here I will start my Kafka server again. So Kafka server started, and let me just try to run this code. So here you can see that when I'm executing this particular code, here it is printing the broker ID. Broker ID 0. The reason is here currently what server is running in our local system is having this broker ID, right? So using this particular command, we can get the broker IDs. Okay. Now let me just create a topic here. I am going to create a topic with partition 1 only as of now. Or let me create, it is not a problem. Let me create multiple partitions. And what I will do, I will just create this. So topic is already existing, that's fine. What I will do here, I will basically give the name and I will hit an enter. So here topic is created. Okay, the earlier topic was already existing, that's fine. Now the topic is created. Now I will start my producer. Okay, the topic name is here what we have given, demo testing 1 2 3, and here I will be pasting that. Okay, and then here I will start my producer. So here my producer started, and I will be opening consumer in a console with the topic name. Okay, I will copy this one and I will paste that, and I will hit an enter. Right, so here our consumer started, and here our producer is also started. If I just type hello world, hi, school, welcome, something I'm just writing, and once producer is producing, here you can see the consumers are also consuming, and here you can see in the Kafka logs, if you go, which we already did a setup in the server logs, currently we are having only one server running, so only in one server only we will be getting all the logs. Here you can see demo testing 1 2 3, first partition, second partition, third partition, fourth partition, and fifth partition, because we have created the topic with 5 partitions, so 5 folders are created. but we are having only one server running, so all the partitions are creating only inside these server logs only in same place. Okay, these are all present in a single broker, inside a single broker only. So if that broker goes down, the producers and consumers cannot produce message or consume the messages. Okay, so inside this partition, if I go, somewhere the messages will be stored, like here hello world is coming, like that. In different partitions, different messages are going randomly, which I already covered in my previous video. Okay, now let me just do one thing. I will just close this particular server. Okay, terminate. Yes, now once it is terminated, here you will see that producer is basically throwing an exception, broker may not be available. Okay, that is producer cannot produce. Okay, and even in consumer side, here you will see that broker may not be available, broker may not be available, like that exception is coming. So from this you are clearly getting that in a single server Kafka cluster, if our single server goes down, then the producers and consumer cannot produce message or consume the messages. So I will just terminate this one. Okay, I have already terminated my this broker. Okay, our server, and here our zookeeper is still running. Okay, I will just terminate my zookeeper also. So here I have stopped all my servers whatever running, and now let me show you how you can configure multiple servers, okay, in your local system. Okay, so for that, what you need to do, as a first step, what I will do, I will basically clear all the logs. So here zookeeper, I will be deleting the logs, and in the server logs also I will be deleting everything. Okay, so here our server logs is there. So we are going to start 3 different servers or brokers. So I will be renaming this particular log location to server logs 1. Okay, and then here what I will do, I will just copy this name and I will create a new folder. Here I will be giving the name server logs 2, which will be storing all the server logs for our second server, and then here I will be giving the name server logs 3, which will basically store all the log information for our third server, which we are going to start. Okay, so 3 different log locations created. Perfect. Now what I will do, I will go to my actual Kafka folder where all the scripts are present. I'll be going to config, and whenever we started our server, if you see this particular code, start Kafka server, there we have given server properties. Okay, so earlier we were having only one single server, so we have given server properties. Now we are going to have 3 different servers running in 3 different ports. So we need to create 3 different script for our 3 different servers. So here I will just rename. So here I will be giving the name server1.properties. I will just copy this and I will paste that here, and I will rename to server2.properties. I will again paste that here, and I will rename this server3.properties. Okay, 3 different server properties file we have created. One will be using for launching our first server, another one second one, another one third one. Okay, I will just edit this one. Okay, so once we edit that, we have to make sure all the different servers are getting different unique names. So like here broker ID 0, for the next one we will be giving broker ID 1, and for the next one we will be giving broker ID 2. Okay, fine. And then here you can see that log directory we have to change. So what is the log directory? So for the first server, all the logs information we want to store here. Okay, so I'll be just taking the folder name, and here I'll be pasting that. Okay, so for the first server, whatever logs will be generated, that will be getting stored in this particular folder, server_logs_1. Okay, right. And here rest of other properties are almost same. Zookeeper is basically running at localhost 2181. Looks good, this one. Now let's go to our second server properties. Server properties 2 I have opened. So broker ID, I have to give a different ID because already I have given broker ID as 0 for the first server. So I'll be giving broker ID 1. Okay, right. And then here I have to change the log location. So for the first server, the logs are stored in server_logs_1. For the second one, it will be stored in server_logs_2. Okay, right. Number of partitions, default one we are keeping 1, fine. And one more thing we have to change, that is port where it will be running. Okay, zookeeper connect is fine. Here if I go little bit up, here listeners we have to change. Okay, so here also I think listeners we have to change. Make sure that here listener is port 9092. This server will run in 9092. Okay, and this server will run in port 9093, right? So I will just save this one. Broker ID I changed, listener I changed, and apart from that the log locations I changed. Okay, and for this third server also I have to do the same. So for this one I have to give broker ID 2. Okay, because for the first one I have given 0, for the second one I have given 1. So for this one it will be broker ID 2, and it will be running in 9094, another port. Don't give same port number for different brokers. Okay, first one is running in 9092, second one is running in basically 9093, and third one is running in 9094. Perfect, right? And also we need to change the log location. So here what I will do, I will basically copy the log directory from the first server and I will paste that here. I will just change that to server logs 3. Okay, so this is our third server properties which is done. Okay, right? Zookeeper anyway going to same, because in our local system the zookeeper is only single one which will be monitored the different servers. Okay, so 3 server properties we have configured. Okay, now we will start our Kafka server. First one I will be starting. So here we need to give the property file name. So for the first server we will be giving the property file as server1.properties. Okay, so it will be taking all the properties from this particular file, right? So let's start our process. So as a first step, what I will be doing, I will be starting my zookeeper first. Let me just check one thing, that whether log locations are cleared or not, because I just want to show you the demo from scratch in a fresh Kafka cluster. So everything is fine, cleared. So here I will start my zookeeper server. Okay, so here you can see that it is running in default port 2181. Now here what I will do, I will start my first Kafka server. Okay, paste it and I will hit an enter. So here you can see that the Kafka server is started. Okay, right, first one ID 0. Okay, and now what I will do, I will start my second Kafka server. Same code, just server properties will be changed. It will be taking the properties from server2.properties. Okay, that's it. So here I will go to my another terminal, and here I will paste that and I will start my second server. So here you can see for this broker the ID is 1, it is started. And if you go a little bit up, here you will see that it is basically started in port 9093. Okay, see, port number is 9093. For the earlier one the port number was 9092. Okay, if you see here, plain text desktop 9092. Okay, I'll be opening my another terminal, and here I'll be starting my third server which will be running in port 9094. Okay, so here I will just copy this one and here I will paste that one. Okay, I will hit an enter, and here you can see that our next Kafka server, which is having ID 2, that is also started, and here it is running at port 9094. Okay, so let's just confirm once whether our all the servers are running or not using this particular script what I already discussed, that ls broker IDs if you use in the zookeeper shell script, it will be giving all the IDs which is running. Okay, if I just hit an enter, here you will see that IDs are 0, 1 and 2. That means now this time 3 servers are running. Earlier we were getting only 0, right? So now this time 3, that's fine. Now what we will do, we will create our topic. Okay, so always it is good that whenever you are creating a topic where you are having more than one server, then instead of one server you mention all the servers. Okay, that way if one server is down, if others are up and running, these topics can be used for communication purpose. So another bootstrap server where our server is basically running, that is port number 9093, another one is 9094. Okay, Replication factor, till now I am keeping only 1. I am going to discuss what is the importance of replication factor in my upcoming video. As of now, let's see how multiple partitions are working for a topic in multiple server Kafka cluster. Okay, right. So just let's create the topic. Okay, here I have mentioned all the servers: localhost 9092, 9093 and 9094. 5 partitions I am creating, and here let's see. So here demo testing 2 is successfully created. And now let's see. I have already told you in theoretical discussion, right, that Kafka never create all the partitions in same server, because if that server is down, then if all the partitions are in same server only, then the topic itself cannot be used. Okay, but if the partitions are distributed among different servers, then if one is down, at least other partitions will be accessible, right? So let's see whether that is happening or not. I'll be going to Kafka logs. Let's go to the first server. Okay, so here server logs 1 is basically storing all the logs for our first server. Here you can see for our topic demo testing 2, 1 and 4, these 2 partitions are created. Okay, I will go to my second server logs. Here you will see 0 and 3, these 2 partitions are getting stored in second server. Okay, in the third server, if I go, only the partition 2 is coming in this third server. Okay, like that randomly it is arranged. So that's fine. Now let's start our Kafka producer. So whenever we are starting producer, then we will be mentioning multiple servers, because for reliability purpose, and REST script is as it is. So I will just rename the topic what we have created, demo testing 2. Okay, and then here we will start our Kafka producer. Okay, so here it is started, and the producer can publish the messages in all the partitions distributed across multiple servers. Okay, and this is our consumer. The consumers also will be starting with multiple bootstrap server, and then here I will copy this one. I will go to CMD and I will start my consumer. Okay, so here demo testing 1 to 3. What is the, sorry, actually the topic name is demo testing 2. I have given wrong topic name. So I will just run this code once more, and I will hit an enter. Okay, so here our consumer is started. So now let's see whether producers are producing messages and consumer can consume them or not in this multi-node cluster. I will just take side by side, and hi, this is the first message. Okay, I will hit an enter, and see automatically it is coming to consumer. Okay, hello, second one, hi there, third one, so here you can see producer or consumer are exactly working how it worked in a single server Kafka cluster, right? Same thing, producers are producing messages and publishing, consumers are consuming messages. Okay, something I have written. So here you can see consumers are able to consume all the messages. Okay, now let's see what happens once our any of the server is down. Earlier we have seen that once one server is down, the complete process is stopped. Okay, but before that, let's see how the messages are arranged. Okay, so here if I go to server logs 1, here you will see that demo testing 2, which is our topic name, for that 1 and 4, these 2 partitions are stored here. Okay, so if I go to this particular partition and if I open here, test 1 2 1 2 2 3. Okay, this particular message is stored in this partition. So I'll be just noting it down, which messages are basically stored in which place. So what I will do, I will just copy this particular stuff and I will paste that here. This message is basically stored where, this message is stored here. I will be just saving them so that I can show you the demo properly. So here this particular one, test 1 2 2 3, is basically stored in our partition 1 in first server. Okay, right, I will close this one. So I will just do this activity once, and let's just go here. Here you can see hello second one, welcome. Both are basically stored in the first server partition 4. Okay. Partition 4, as you can see here, welcome is stored and hello second one. Just copy this one and hello second one. This message is also stored in partition 4 in the first server. Okay, fine. I'll close this one and then here let's go to the second server. Let's see what are the messages stored there. Okay, so here demo testing 2. For that only third partition is available here. I will just open this one. Here you can see hi there third one. Okay, right. So here I will be hi there third one. That is, this message is basically stored in our second server partition 3. Okay, just call this one partition 3 second server. Okay, and then let's go to the last server. Here we are having only one partition. I will just open that one. Here you can see fourth message coming. Okay, this is basically stored in server 3 partition 2. Okay, third server, but fifth message is stored where, that we have to check once. Demo testing 2.0. Here, hi, this is first message. Okay, hi, this is first message. This I have written, right? Okay, I have not written this one. Okay, I think I missed this particular partition, that is in our second server 0th partition. Okay, so this is second server and second server, this is partition 0. Okay, partition 0. Similarly, here in this partition only you can see fifth message testing. This is also present in the same partition. Okay, so I will just close this one and I will copy this, and this is how our messages are getting distributed. Okay, so you can understand that in different servers, in different partitions are stored randomly, and inside them the messages are going. Okay, now let's just close this particular consumer once. I will just come out, and now let's see, here our producer is running. What I will do, I will stop one particular server. Okay, so let's consider that suppose we are stopping our second server. Okay, so second server, what are the second servers? Like here, this message is stored in second server, this message is stored in second server, and this message is also stored in second server. Okay, so once our second server will be down, what will happen? This partition 0 and partition 3 will not be accessible because they are basically inside second server, but other message our consumer will able to get. Okay, so like here now, this time if I just start my consumer, if I just hit an enter, here you will see all the messages whatever we have published from producer, that it is able to consume, right? Because our all the servers are running. But just now let's do that activity. Let's just stop our second server. Okay, so here in the first terminal our zookeeper is running, in the second terminal our first server is running, in the third terminal our second server is running. Okay, so I will just stop this one. And here if I go back to my producer, here you can see producer is still okay. Okay, right? And now what I will do, I will start my consumer and let's see what is happening. Okay, so in consumer still we have mentioned all three servers, and I will hit an enter. Okay, let's see. Let me just close this terminal and open a new console and start the consumer. Here you will see what is happening. Earlier, when in our single server Kafka cluster, if the server is down, then even we cannot start the producer, consumer, anything. But now we are able to run our consumer, okay, and see what is happening. Our second server was down, right? So second server was storing this message. Hi, this is first message, okay. Then hi there, third one, okay, and fifth message testing. See, apart from those messages, all the messages are coming. Why? Because this message, hello second one, this is basically stored in our first server, okay. Then welcome is basically stored in our first server. Testing 1, 2, 2, 3 is basically stored in our first server. And fourth message coming is basically stored in our third server. So whatever servers are up and running, from them, our consumer is able to consume the messages, okay. Even suppose I am basically producing one message, hello testing help. I will hit an enter and here you will see the message is also coming, hello testing help, okay. So that means producer and consumer can work freely although our one server is down. Why? Because our other servers are running, okay. But what consequence we have to face if we are having this kind of setup? That is, here our suppose broker one, whatever partitions are stored, if the broker one is down, then in that partitions whatever message are stored, that we cannot access. Like here you have seen that when we started this new consumer, it was not able to get the messages whatever was stored in our second server, okay. That is, hi, this is the first message, hi there, third one, or fifth message testing. Nothing is accessible to our newly created consumer, okay. Now let's start our second server again, okay, and then see what is happening. So I will just come out and I will just close this particular terminal. I will open a new terminal and there what I will do, I will go back to my second server code and here you can see server 2. So basically all I am doing, I am starting my second server again, okay, to show you that once the server is again up and running, all the messages will be getting consumed as it is, okay. So let me just start my consumer script, okay. And if I just hit an enter, here you will see that hello, this is the first message, okay. Here you will see, hi, this is the first message, okay. Hi there, third one, hi there, third one, fifth message testing, fifth message testing, everything is again started coming, okay, right. So I hope you understood the importance of multiple servers in our Kafka cluster. But still there is one problem. And what is that problem? That is, although our multiple servers are there and if one server is down, other servers can fulfill the need. But when one particular server is down, whatever data is present in that particular server already, that cannot be consumed by any consumer, whatever is running newly or something. So we need to replicate the data from one server to another server. Hope you are getting that importance. And that's where our this replication factor comes into picture, which I am going to cover in my next video. So this is all what I wanted to discuss with respect to multiple servers in our Kafka cluster with multiple partitions and replication factor 1. In my next video, I am going to cover multiple servers, multiple partitions Kafka topic, and with more than one replication factor, what we are going to observe, okay. So if you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you.